Come on. If we get through the review, then you can have your conversations at the end. But let's do this. Okay, reference angle. The reference angle, guys, okay, reference angles, remember, is all our triangles started in quadrant 1. So say this was a 30. When we reflected it somewhere else, this still stays the reference angle. The little angle inside the bow tie is the reference angle. It's the little acute angle that came originally from quadrant 1. Now, if we ask where 252 is, 252, and label this, if this helps you. It's past 180, but it's not quite up to 270. So it terminates, here's our angle, open in standard position, terminate, terminal side. If this is 252, how far from 180 am I? That's my reference angle. 252 minus 180.
Is that 252 degrees?
Yes.
Oh, I thought it was 252 over 0.
That's degrees.
Oh.
I want this little reference angle right here. I want the reference angle. Remember, the reference angle is between the terminal side and the x-axis. It's the angle between terminal side and x-axis. Remember, all your triangles are drawn to the x-axis like a bow tie. So these are your reference angles right in here. They're all acute little angles. So as I rotate around here, I pass 180, I terminate here. I drop my triangle. I know we don't have a special triangle for this, but this still is a reference angle. That means 72 has the same sine and cosine as 252, except for this guy in 252 has a negative sign there. But the value has to be the same thing. The cosine of 72 has the same cosine of 252, except in quadrant 3, oh, my cosine will be negative. But the value itself has to be the same. And try it on your calculator. Do the cosine of 72. Do the cosine of 252. It has to be the same number, but obviously one will be positive, one will be negative because of where we terminated. But that little angle is our reference angle. Now, when we give it to you in radians, take this number. Make this number be the same over here because this has to reduce to pi. This has to reduce to 2 pi. This is rotating clockwise, the opposite way. God bless you. So I'm coming past 5 pi over 5 to get to 6 pi over 5. I terminate right here. I drop my triangle. This is my reference angle. My reference angle is the same guy that came from the very first quadrant. So look, here's a little shortcut. Just cover the 6. What's your reference angle?
And how did you get it to terminate right there?
Because we went the opposite way. We started like this. We have to go this way because it's negative. We said, take this guy. This becomes 5 pi over 5. It has to reduce to pi. This is doubled. Sorry. It's really 2 pi. We doubled. 10 pi over 5. So if we're coming around here, we're 5 pi over 5. We're 6 pi. One more. What's 6 minus 5? There's my reference angle. Or to cheat, just go like this. Doesn't have to be the single one. How many times does 5 go into 180? How many times? 36 times. So, isn't this a 36-degree angle? What is pi over 5? 36. So isn't this my 36-degree angle? But do it in radians. Don't even flip them back and forth. Do you see a pattern? Here, let's do 6 pi over 5. Let's take away the negative sign. What quadrant will that terminate in? 6 pi over 5. Third, because I'm going to open up like this. This will be 5 pi over 5. This will be 10 pi over 5. I come over here. I got to go one more pass to 6 pi over 5. What is 6 pi over 5 minus 5 pi over 5? 1 pi over 5. Isn't that my reference angle? Didn't we do the same thing over here? What was 252 minus 180? Right? So what is 6 pi over 5 minus 5 pi over 5? But your reference angle is that right there, pi over 5. Is this right there? It's the little acute angle that sits right in here. Let's flip this to degrees. How do I change this, God bless you, to degrees? Multiply it by what? I want to get rid of the pi, so 180 over pi. Out comes this. 5 goes into 180 how many times? We said 36 times 6. What's 36 times 6? Is that 216? So it comes all the way around 216. What's 216 minus 180? Oh, 36 degrees. Doesn't it work the same way? Radians should be easier to add and subtract. Use your 5 pi over 5, 10 pi over 5. If my angle is pi over 7, 7 pi over 7, 14 pi over 7. You're either going to go one up or one down. One up, one down. My last guy is 17 pi over 3. So I start like this, 3 pi, 6 pi. I rotate around. I pass the 3. I come to the 6. I'm past the 6. If I add 3 more, what is this? 9. I didn't hit 17. 12. Add 3 more. 15. Add 3 more. This is 18. I only needed to go to 17. So there I am in the 4th quadrant. And what is this angle? Pi over 3. If this is 17 pi over 3, whoops, and this is 18 pi over 3, just subtract them. Oh, it's 1 pi over 3. That's my reference angle. Pi over 3 is what angle in degrees? 60. That one has a nice special triangle we could use. Sometimes they have special triangles, sometimes they don't. I would not ask you to label your triangle if it wasn't a special triangle. So let's review those guys. Special triangles. What's the side opposite 30? 1. The side opposite 90? 2. The side opposite 60? Radical 3. 45, 45. What's the side opposite 45? 1, 1, radical 2. Make sure you know those two triangles. Okay? Alright. Alright, so let's take a look at these guys. Basic triangle trig. Later, do you have your review? Let's see.
What does it look like? This is it.
The blank one? The blank one? Oh, Lisa. Okay. This is your review for your test, guys. The 6 trig functions. If you find the basic 3, sine, cosine, tangent, how do we find their reciprocals? Just an easy way. Flip them over. So find those first. The nice part is you do not have to rationalize denominators. That doesn't mean you don't have to simplify to lowest terms or simplify your radicals. You just don't have to take a radical out of the denominator. So if we look at your triangle, here's my angle of reference. This is my opposite side. This is my hypotenuse, always opposite the right angle. This is my adjacent side. Adjacent means right next to me. It shares one of the rays of the angle. Opposite, like opposite the table from you. Okay, so now, set this up. Opposite, if you want to set it up, opposite is part I don't know. Adjacent is 4. Hypotenuse is 9. Okay, how do you find the missing side of a right triangle? Pythagorean theorem. Be careful how you set this up. This guy is my hypotenuse. 9 squared equals 4 squared plus b squared. And solve for b. B gives you radical 65. Can I reduce radical 65? There's no perfect square factor that comes out of 65. So set them up. Flip them over. Remember your reciprocals. Tangent and cotangent start with different letters, but they sound the same, right? Tangent, cotangent. They start with different letters. So remember your sine and your cosine have to start with the opposite letter. So this time my sine, my reciprocal starts with a C, my cosine starts with an S. Just so that you remember they're not the same letter. Again, you're over here, you need to find your hypotenuse this time. Your hypotenuse says 10 squared plus 12 squared equals c squared. Now, you have to reduce this guy. So, divide it by 2, divide it by 3, divide it by 4 until you can see where you get to. It divides nicely by 4. 4 times 61. 61 can't be reduced at all. So, 2 radical 61. When you set this up, as you do this, each one of these you're going to have to reduce to lowest terms. Reduce this right here. Everything has divisible by 2. Take the 2 out right here. Otherwise, you're doing this. Sine. If I say 5 over radical 61, I'm going to have to say 10 over 2 over radical 61. And then I'm going to have to reduce this. And then I'm going to have to do it again here. Do it again here. So do it once when you set up your information box. You tell me, what is this looking like? This is your review. I'm sure if you did it early on, you didn't look at it for the past week, so absorb.
No, third.
Third quarter. Second quarter's done. Good so far? Good so far. Well, we really haven't done too much different than Algebra 1, Algebra 2 yet. Even Algebra 1, it does this. Okay, another way to look at it is what if I give you a point on your xy axis. Here's your xy axis. I give you the point 12, 16. 12, 16 resides over here. I want an angle that opens up and comes up here and terminates. So I drop a triangle. My x, my y, my 12, my 16. Do Pythagorean's theorem, find your missing part. Okay? And make an information box. I'm real big on information boxes. Once you do this, you never have to go back and look at your diagram again. These are all divisible by 4. Divide them here. Otherwise, you're going to find yourself dividing them here. 16 over 20, you got to reduce it down. 12 over 20, you got to reduce it down. Reduce them once. That's your 3, 4, 5 triangle. If you spotted it, you didn't even have to do Pythagorean's theorem. If you spotted that 4 goes into here 3, 4 goes into here 4, and you started this, 3, 4, you knew this had to be 5. Make sense out of this. Okay. Do your x, y, and r. But when you do this with your x, y, and r, and you set these up, this takes care of where your negatives are. So do you have to keep track of who's negative? No, because anything that deals with the x negative has a cosine that's negative. Anything with the y of negative has a sine that's negative. And then tangent, you have to look at y over x. 2 negatives will give you a positive. This guy, again, come to this quadrant, set this up, reduce this. Reduce it before you start. Make sure your radicals are reduced as well. Okay, you with us? Come on, you have a test tomorrow. I know it's tough getting up out of bed after a week of not getting out of bed. Questions? You guys ask me. I can't remember it. I wasn't sure what to do. Jeremiah.
For radical, do you always have to reduce?
Yes, you do. So this one said 4 squared plus 6 squared equals r squared. I never put the negatives in because if you do the negatives in your calculator, you've got to have parentheses. So any negative is always a positive. So when you do this, you have to find what goes into here that has a perfect square. It's a small number divided by 2. 2 times 26 doesn't buy me anything. 3, not going to help me. 4 goes in here. 4 times what? 4 times 13. 13 I can't reduce anymore. So 2 radical 13. Reduce them down. If you get something like radical 72 and you say this goes in, say you say it goes in 8 times 9. Can I reduce 8 down any more than this? To what? 4 and 2, right? So just go like this. Don't erase it and start all over. So, what's the square root of 9? What's the square root of 4? 2. So what's 3 times 2? You can do it right from there. If you don't get it right the first time, at least start breaking it down. Break it down, keep breaking it down. Multiply all your numbers that come out as perfect squares and leave your radicals that are not. But do not pick up your calculators for these. When they say exact value, they mean exact values. Questions? Okay. Now we get a little trickier. I give you a function, and if I just gave you the secant, you could say secant is the reciprocal of which one? Cosine. So I'm going to turn this over to cosine because I don't really like looking at secant. So if I take that reciprocal, I take this reciprocal. Now, cosine is my x. It could be positive in 1 or 4. So how do I know? I gave you a little bit more information. Out of those two quadrants, where is tangent? Negative. Less than 0. Negative. Out of 1 and 4. Everybody's positive in 1. So in 4. So I don't want this guy. I just want quadrant 4. I had to give you another piece of information. So now, I know x over r. There's my x value. There's my r value. Pythagorean theorem says 6 squared equals 5 squared plus b squared. Subtract my 25. And there's my other piece. Now, when you get to here, this is where you label who's positive and who's negative. In quadrant 4, my x is positive. But my y down here is what? Negative. Label that with your negative. So now when you do this, they all fall into place.
Tangent is negative and quadrant 4, you know that because why?
Because the x is positive and the y is negative. Tangent will be positive. Out of 1 and 4, everybody's positive in 1. So tangent can't be negative in 1, right? It had to go to 4. But tangent is positive in 1 and 4, wherever your x and y's are exactly the same signs. So my x and y are both positive in 1. They're both negative in 4, so a negative divided in 3. Sorry. So a negative divided by a negative gives me a positive. So 1 and 3 is positive. Okay. That's why we like to use the grid to help us. And then from there, this is your y over r, your x over r, your y over x, and then these guys flip. Okay? Number 9, cosine. Cosine is my x. My x is negative over here. So I could either be in 2 or 3. You get a little bit more information. Out of 2 and 3, I want where my sign is positive. My sign is what? My x or my y? Y. So is y positive up here or down here? Up here. So So I don't want this guy, I just want this triangle. So I label my parts, x over r, I find my missing part, I don't have any perfect squares in 21. I set this up. Now in this quadrant, use your grid. Your x is negative, your y is positive. And that'll help you figure all your signs as well. Then take your reciprocal. Feeling good about this? Feeling okay? Okay, the next part, we get to your special triangles. Normally they'll say, find this exact values. I said don't use your calculator. These are your special right triangles, or your quadrantal angles. They're on your quadrants. They go off your unit circle. Over 1, down 1, up 1. And x is your cosine, the y is your sine. So tangent of pi over 3. So this is 1 pi over 3. How many times does 3 go into 180? 60. So I've got a triangle in quadrant 1 with a reference angle of 60. That's my special triangle. Opposite the 30 is 1. Opposite the 90 is 2. Opposite the 60 is 3. So again, x is 1. Y is radical 3. R is 2. I just want the tangent. Y over x. Y over x. Now try not to leave it to me over 1. Just reduce it down. It's not wrong, but give it to me as radical 3. Now I did this for a purpose, and some of you saw this before when we did this in class. This is the same reference angle, is it not? Is it not pi over 3? Same 60-degree angle? But we put it in a different quadrant. So now I'm 5 pi over 3. So here's my 3 pi over 3. It crosses out the pi. Here's my doubled, 2 pi. I come around. I terminate here because this is 6. 1 less is 5. I have the same exact triangle. But look what happens. In this quadrant, 4, 1 is positive, but the y is negative in quadrant 4. Because my y is down here, where my y's are negative. My radius, always positive. Your radius is a distance from the center to where it terminates on the circle. So that's always positive. Can I find my sign? Y over r? Absolutely. Okay? Then I just had you pick up your calculator, just so that you get used to setting your calculator to degrees. This mode says degrees. This mode, what's this mode? Radians. If you wanted to, could you convert that to degrees if you wanted to? But why do the math when you can just change your mode? God bless you. Good so far? Okay, find 2 values. Now I asked you for 2 values because cosine, sine, tangent has 2 positives, 2 negatives. 2 quadrants where cosine is negative. Cosine, easiest way to look at it, guys. Don't memorize your all students, take chemistry, whatever you say. Just go to cosine is my x value. Where on my grid is x negative? Oh, I find my x-axis right here. So what quadrants must my cosine be negative? 2, and 3. Use your grid. It makes so much more sense. So if you didn't unrationalize this, I unrationalized it. But if you didn't, it set this up here. It said, okay, here's my triangles. This is my r. This is my x. So let me do radical 2 squared plus b squared equals 2 squared. A radical times itself comes out. Subtract my 2. Oh, this side is also radical 2. Well, if both of those sides are the same, what angle do I have there? 45. When both legs are the same, right? I have a 45-degree angle. So that's a 45-degree angle. So whether you unrationalized it or not, that was a 45-degree angle. So in degrees, if this is 180, you always go to the x-axis, never to the y. I'm 45 degrees short of 180. So I'm 80 degrees minus 45. I'm 135. I'm 45 degrees past 180. I am 180 plus 45. I am 225. Now in radians, how many times does 45 go into 180? 4 times. So this guy, 4 pi over 4. This guy, 8 pi over 4. So as I come around, I'm 1 short of 4 pi over 4. What am I? 3. This one, I'm 1 past 4 pi over 4, so I am 5. If you need to, do it in degrees and convert it. If I want to convert degrees to radians, I need the pi, so I'm going to multiply it by pi over 180. Look what you just did. You made a fraction out of this guy. You said, how many times does 45 go in here? 45 goes in here. 45 goes in here. 3 pi over 4. It'll work out the same. Don't cross multiply those. Reduce those. But try to work in radians. It makes life so much easier. And especially when we start the next one on Wednesday, when we start graphing, we graph in radians. So I'll get your mind all twisted over to radians, and you'll say, what's a degree? Okay, cosine. Oh, sorry, cosecant. If you don't want to work in cosecant, what's the reciprocal of cosecant? Sine. Use that reciprocal, use that reciprocal. Same difference. It's still going to be y over r over y, whichever one you set up. Now my sine uses my y. So y is negative right down here, isn't it? So what quadrants am I in? 3 and 4. Doesn't that make sense? So I drop a triangle. Aren't those two congruent triangles? They have to be exactly the same. So I need this reference angle. So my y is 1 over r. I didn't need to find this if I didn't want to, because I know this is my 30 degrees. Now 30 comes, 30 is past 180 is 210. 30 degrees short of 360 is 330. 30 goes into 180 6 times. So if this is pi, this is 6 over 6. This is 2 pi, this is 12 over 6. So again, 1 past the 6 is your 7. 1 before the 11, the 12 is your 11.
How did you get those triangles? Those specific triangles.
Did you work over cosecant, or did you flip the sign? So you said, where is my sign negative? My sign deals with my y, right? On your axis, my y is positive up here, my y is negative down here.
Yeah.
So they have to be here.
So once you do that, there's 2 triangles that have to be put down.
Yes. Yeah, that's what I said, find me 2 values, because I didn't limit you to 1. I said 2. Yeah. Good? Question? No? Easy? Good. Coming back to you? Good. Okay? Some of your applications. Your goal is to find your right triangle. Now, whenever we're looking for a height of something, That's your perpendicular line to the base. It even makes a little H when you make a perpendicular box in it. So a surveyor is trying to determine the width of a river. From point P, the engineer walks downstream to point O, and he makes a little sighting there. So he walked 125 feet, and he noticed that his angle back to the original was 62. He gave you the right triangle right here. We need to know, how wide is your river? This guy right here. Whoops. How wide is your river? It's sometimes a little difficult if they don't give you a diagram to see what you're looking at, but he gave you the diagram. This is a right triangle. How wide is this? Because you wouldn't measure something and say, that way, how wide is it, right? You'd always measure your perpendicular line. It actually gives you the little h height. So this is an opposite side. This is an adjacent side. This is always your hypotenuse, opposite the right angle. So we got tangent. But make sure that when you do this and you cross multiply, that you multiply this, but make sure also your mode is degrees and that you close that parentheses. Because if you're going to do it this way and you don't close your parentheses, it's going to multiply your angle. And make sure your mode is degrees. Hang in there. Okay? Picture an escalator at a mall. An elevator goes straight up. An escalator has a set of stairways up, right? So your escalator can't bring you up like this. Walking on a step, you'd never make it. You'd fall right off. So an escalator, here's my escalator going up. My escalator is 152 feet in length, and it rises up to like the next floor. Makes a 30-degree angle with the ground. So we drew the right triangle. We want to know, find the height of the platform of, like, say this is the next level of the mall. What's the distance between here and here? So again, we said it makes a 30-degree angle. We're looking at an opposite and a hypotenuse sign. Make sure your mode is degrees when you multiply. And make sure it makes sense to you. Like, if the right angle, the side opposite the right angle has to be the largest side. Has to be. So if this one came out greater than that, something went wrong. If it came out negative, means you probably are in radians or some weird thing. So don't just cross off the negative sign, as I see some kids do. Find out why it didn't come out right. Good? Okay, and I think this is your last one coming up, right? This is a tough one. Now, we keep life very basic. We keep the right triangle trig. There's no trig for non-right triangles. We don't do non-right triangle trig in pre-calc. So everything is going to be based off of a right triangle. Now, the tricky part here is, here's my passenger in an airplane. He's driving at an altitude of 3,700 feet. Okay? 37,000 feet. And he sees two towns as he looks down. When he's way up here, this is his horizon. When he looks down, this is his angle of depression. It is the same as the angle of elevation. Think of it like two parallel lines cut by a transversal. This angle is this angle. This angle is this angle. Now, where's my right triangle is the problem. He still is 37,000 feet. Just drop it from where all these points meet. That's 37,000 feet. They're showing you, yes, there's 37,000 feet high, but combine it where all your pieces are. So you have one small triangle here, and then you have one large right triangle sharing the same side as this. They both share that side. This guy is this piece right here. I called it X. This red part, I called y. If we subtract them, we get z. Okay, doing that like this first. And then notice, I've got two triangles that are tucked into each other. If you want to separate them, separate them. This guy is going to give me this one. It's 76. It still has the same side here. I need to know this piece here. So now, when you cross multiply, notice it didn't say y equal. Then divide by tangent, solve it for y equal right now. Don't put it in your calculator yet. Do the same for this guy. Take this guy out. This guy's a little bit longer, but he still has the same side over here. I want this piece. Solve that piece for x. It's still a tangent. And then you're going to take that and you're going to do x minus y. You're going to just subtract those two. And that will equal what's left over in here. This piece between them. That's the piece between them. Don't get hung up like on where did the buildings fall, like in the middle. Just basic length of your triangle. Superimpose your triangle right on top of that. And that'll make it a little easier.